All right, we're back here for part 4. We're going to summarize just a little bit more here our important ideas from this. So idea number 1 is we always have to check conditions. Always check conditions. So we need to have random. That allows us to generalize our values. We need to have 10%, or we have to assume independence, less than or equal to 1/10 of the total population of that. And we need to have the normal condition, which if they tell us the population, the true population is normal, then we can go ahead and use that. We can use the central limit theorem, n is greater than or equal to 30. Or if we have no strong skew or outliers. Big idea number 2 is we have to get the test statistic, which is not z, it is t. So t is equal to the sample mean minus the population mean, or the null, what we think the null is, divided by the standard deviation of the sample divided by the square root of n. And when we do that, what we're getting here is a t distribution, not a normal distribution. So t with degrees of freedom. Now in this case, we could have said this was t and this was for 19. The degrees of freedom was 19. Big idea number 3 is the p-value. Now you can use the table You can use table B with degrees of freedom, and if you know the tail probability. Okay, or the quicker way is to do TCDF, where you have your lower bound, your upper bound, and then your degrees of freedom. So what we did, what I was doing at the end here, when I did my test, t-test, okay, all of this was in here, and calculate, oh, sorry. TCDF, that's what I wanted to do, apologies. So TCDF, okay, right there. Now, lower bound is negative infinity. The upper bound was our t, our statistic, 1.5377. And the degrees of freedom was 19. And there was our 0.0703. Okay, so we had that. Now, one last thing to mention here when we do this test, when we do the t-test like this, you have 3 choices when you're looking at your alternative hypothesis. What if the question had been, okay, now I know this is the very bottom of my paper here, but what if the question had been, is there convincing evidence that the average, I'll say number of hours of sleep, is different from 8, is different from 8. How would that have changed the game? What would that have done if we had wanted to do that? Well, our H null would have been the same, that the true mean is 8. Our alternative hypothesis would be that the true mean is not 8, which means it could be greater than or it could be less than. So when we found our t statistic, when we found the test statistic, and then we looked at a t distribution, if we have this situation where we are testing for if the mean is not equal to 8, we would actually have to look in 2 places for this. We would have to look at the lower end, which is what we did. Okay, if we come back to here, this was at negative 1. 5377. That was this value here. But then we would have also had to look at the other tail at positive 1.5377. Now if I did that, just to show you what happens here, calculate. The p-value is 0.1406. Now in our problem, this was 0.0703, but that's only for the left tail. The right tail would have been the same thing. If we take 0.0703 and multiply by 2, because the areas will be the same, they're just on different sides of the distribution, notice we get 0.1406. Okay, so if that happens, if you're doing this using the curve, using CDF, you just take your p-value and you multiply by 2. So 0.1406. Now this is still greater than alpha. So we would still make the conclusion that we would fail to reject H naught. We would say there's not strong evidence that the true mean number of hours that Mr. Cavell's AP Stats students sleep per night is different from 8. So at the very end, we would say there is not convincing evidence or strong evidence. There is not convincing evidence, and I'm out of space, sorry. There is not convincing evidence that the true mean is different from 8. Is different from 8. So it's just the way that I'm phrasing it. And that is the end of part 4.